Question number 16. Now this is from interference. A little bit of phase shift while changing the medium is involved. Two light waves having same wavelength lambda in vacuum are in phase initially. That's right. The first one travels a distance L1 in a medium of refractive index N1. You know, a distance L1 in medium is equivalent to N1 L1 in vacuum. That's how the conversion goes. So what can I write? N1 L1 is the path length in equivalent term in terms of vacuum. Similarly, N2 L2 is the path length equivalent in terms of vacuum. L2 length in medium will produce the same phase difference as traveling N2 L2 in vacuum. That's a concept there. And this is the path difference, right? And the path difference has been calculated, but we need to calculate the phase difference. And how are we going to do? You know that the phase difference will be equals to path difference divided by lambda into 2 pi. Let's hunt. Where do we have that? Okay, 2 pi by lambda N1 L1 minus of N2 L2. So that will be option number 3 as the correct one. 17th question. Question number 17 is something like this. There is a particle moving and that particle is under the influence of an agent which supplies constant power. That is the key word, constant power. We got to see the variation of displacement versus time. We just need the variation. So now one thing is there, the kinetic energy 1/2 mv square will be equals to power into time. Since I don't require the expression, I can directly say that V is directly proportional to t raised to the power half. Further, if you integrate, displacement will be directly proportional to t raised to the power 3/2. We don't require the coefficient. We just need to plot the graph. And S directly proportional to t raised to the power 3/2 because the power is greater than 1. So option number 3 will be the correct one. Let's go to question number 18. Question number 18, that's from semiconductor, but essentially it's related to photon. There's a semiconductor photodiode which can detect, a photon of maximum wavelength this much. Now that maximum wavelength is corresponding to minimum energy gap. And that minimum energy gap itself will be the band gap energy, right? Because that would be the minimum quantum jump. So here you could see delta E will be equals to hc by lambda. You want to calculate it. So this is how it goes. This is 1240 electron volt nanometer. That would be a better constant to memorize. Though you can do by multiplying h and c, and lambda, that's 400 nanometer. So a straightforward cancellation, option number 3, 3.1 electron volt, that would be the correct one.